Hey everyone, in this video we're going to look at Calculus Lesson 1-7, actually proving a limit using the precise definition of a limit. So up here I've written your precise definition of a limit. The limit as x approaches a of f of x equals the limit if for every number epsilon greater than 0 there is a number delta greater than 0, such that if 0 is less than the absolute value of x minus a, which is less than delta, then the absolute value of f of x minus L is less than epsilon. Okay, that's just a really complicated way of saying that we can estimate a value here that will be similar to the y value of f of x. Now, one thing to note is that this is greater than 0 here, but remember, absolute values make everything positive. Okay, so what that means is that this isn't really a necessary part because, well, an absolute value is always going to be positive. So I'm just going to erase this part right here because it's not really all that necessary. Absolute values are always going to be positive. I think they're just saying with that part, just that x and a cannot be equal, because if they were, then you would get 0. So that's the only thing that that part is making. I'm going to focus on, we know that x and a are different, so let's just move on from that. So let's identify the values here. So in my example that we are trying to do, we have proved that the limit as x approaches 2 of 3x minus 5 equals 1. So we need to identify a. A is 2. My function is 3x minus 5, and the limit is 1. Now I'm going to put them into these inequalities. So I have the absolute value of x minus the 2 is less than delta, and I have the absolute value of my function, 3x minus 5, minus the limit is less than epsilon. Now what we're going to do is we're going to find a value for delta. And in order to do that, because we need to know delta before we can actually do this, in order to do that, we're actually going to take this part, we're going to do some math magic with it, okay? Because we have to identify delta first for this part to make the beginning of our conditional statement true, and then we'll be able to show the ending is true. So I'm going to take the ending part and write it down. And we're going to solve it for x, and then I'm going to make it look like my delta inequality. So these are like combined into one step. So this inequality, I'm going to combine my negative 5 and my minus 1. So I have 3x minus 6 there is less than epsilon. Now remember, absolute value just makes things positive. So if I say that negative epsilon is less than 3x minus 6, which is less than positive epsilon, I can get rid of those absolute value symbols because I've taken care of them. The negative value and the positive value are showing. Now I'm going to continue solving for x by adding 6 on all of these spots. So I have negative epsilon plus 6 is less than 3x, which is less than epsilon plus 6. So I just added the 6 to get it away from the x. Now finally, I'm going to divide everything by 3. So I have negative epsilon over 3 plus, now 6 divided by 3 is 2, is less than x, which is less than epsilon divided by 3 plus 6 divided by 3, which is 2. Okay, so that's step 3. Make it look like x. Okay, so, solve for x. Now I'm going to make it look like my delta inequality. So I just need to get this minus 2 in there. So you'll notice if I subtract 2 in all of these spots, I will have x minus 2. So I'll end up with negative epsilon over 3 is less than x minus 2, which is less than epsilon over 3. Now it's almost there, but I need the absolute values back. So it's going to be the absolute value of x minus 2 is less than epsilon over 3. So what I've done now is I've figured out what my delta value should be. This is going to be delta. if delta is this, if I make this epsilon over 3, then I know that this is going to be true. So I'm basically like working backwards. I used what I needed to be true to figure out what delta is, and now I'm going to use that value to tell me that that's true. So the last step of this is to actually write out the proof. Remember, delta is epsilon over 3. Okay, so now I have to say epsilon has to be greater than 0 because that is part of my definition. Epsilon be greater than 0 and delta equal epsilon over 3. Okay, so what I'm doing is I'm setting up the beginning of this sentence because it says if for every number epsilon greater than 0, there is a number delta. Now delta is greater than 0 because epsilon is greater than 0. Okay, because this is going to be a bigger number than 0 divided by 3. So it's going to be more than 0. So let this be true. And then what I'm going to do is I'm going to go ahead and set up the beginning of that inequality. So I'm going to say then, by definition of, or I should write this out more clearly, by the definition of a limit, I know that the absolute value of x minus my a value, which happened to be, let me steal it from here, happened to be 2, has to be less than epsilon over 3. Okay, because I just took this and put it in where the delta was, because that's what I set delta to be. Okay, so we are almost there. Now what I'm going to do is I'm going to again do some math magic with this to make this look like this 3x minus 5 minus 1 is less than epsilon. Okay, so math magic, here we come. I'm going to separate this out again. Negative epsilon over 3 is less than x minus 2, which is less than epsilon over 3. And we can do this because of these absolute value symbols. So I can write this, which can be rewritten as this. Okay, I'm going to multiply by 3 in every spot here. Okay, so I can say which is negative epsilon is less than, now multiplying by 3, I get 3x minus 6, which is less than epsilon. Okay, and I can say this can be combined to the absolute value of 3x minus 6 is less than epsilon. And then finally, I'm going to write this using what I see here. Okay, I need a 3x minus 5 where the f of x needs to be, and the limit is supposed to be 1. And remember, this is the absolute value of 3x minus 5 minus 1. And that is equal to negative 6. Okay, so I need to write which can be rewritten as this is less than epsilon. Okay, so this is exactly what I needed here. F of x minus L is less than epsilon. Okay, so I'm going to say finally, as a final summary, so by the definition of a limit, the limit as x approaches 2 of 3x minus 5 equals 1. And that's my proof. So make sure if you have any questions, you ask me about it, because this is kind of an odd process. So don't forget to bring those questions to class.